we are going to use linear models to solve problems. And a linear model is any model where we have an output, like y, equal to something times an input plus a constant. And they can be written in other variables. They don't have to be x and y. We could have something like f equals 265t plus 2728. That's perfectly allowed as well. This is just an example. But how we know this is a linear model is that the f and the t only have multiplication at best going on with them. There's no squaring, no powers of any sort, just multiplication and addition. So let's look at our first example. A simple measure of cost is C equals AX plus B, where B represents the fixed costs of operating a business and A represents the cost of manufacturing one additional item. So that would be parts. That would be the cost, a little bit of the process of putting it together. But a lot of things end up in B. The rent for the building, paying your employees to manufacture the bike, different things like that go into B. And utilities goes into B. You're paying your utilities every month, where AX comes into play with the pieces to make the bike. So let's create a measure of a cost for making X bicycles in a day. So we're going to leave the C alone, but we want to know for this one, suppose that a small bicycle manufacturer has a daily fixed cost of $2,000 and each bicycle costs $80 to manufacture. So we're going to start with our C, so this is part A, equals A is our per item cost. And our per item cost is per bicycle in this case, and each bicycle is $80. So we're going to put our $80 right here, times the number of bikes we make, plus our fixed costs, which is $2,000. So here is our cost measure. If we know what X is, we can find our matching C. In the similar vein for part B, now we want to know how much money it costs to make 5 bikes. We're going to use the same formula. C equals 80 times, we're making 5 bicycles. We're going to add 2,000 to that. 80 times 5 is 400, plus 2,000 means that my cost for making 5 bikes is $2,400. In a very similar way, we now are looking at part C, where how many bicycles can be manufactured for $2,800? Well, that $2,800 is the cost, so that goes into C. So 2,800 equals 80x plus 2,000. Now we solve for x. Subtract 2,000 from both sides. Get 800 equals 80x. Divide by 80. And see that 10 equals x, or 10 bicycles can be made for $2,800. And so that's using a linear model to solve an applied problem.